Hello, welcome to Kubernetes class. Today we will learn what is a service, how to create a service, why need a service, service load balance types. First, what is a service? Service is access point of the group of pods. Service has four types. Cluster IP. Cluster IP is default service type. Cluster IP is the internal IP for cluster, cannot access from outside. Node port, expose port of node. I can access my app on the port from the outside. It's usually for debugging app in dev environment. The port range from 30,000 to 32,767. Load balancer. Your cloud service provider will provide load balancer for your Kubernetes cluster. External name. Expose service or DNS name. How to create a service? kubectl apply, minor f, and YAML file name. The command is able to create a service. Also, the apply command is able to create any Kubernetes resource. The resource type based on your YAML file definition. Let me go through the YAML file. The YAML file has two parts and separated by three manners. First part, create pod, use deployment resource. The content is same as previous deployment class. You can go to my deployment class to get all details. Second part, used to create a service. Fourth section, API definition. API version is V1. Resource type is service. Metadata, name equal to Spring Boot demo. Second section is spec. Selector. Selector used to select pods. Which one has metadata app equal to Spring demo. Back to deployment resource. The pod created by deployment. The pod has metadata. Labels has value app equal to Spring Boot demo. The selector will select metadata based on the pod spec labels. Ports. Protocol is TCP. Port is 999. Target port. Same is 9999. That the port will match container port 99999. Open my terminal to log in Minikube VM. Let me run the command. The command will create two resources, a service resource and endpoint resource. Endpoint resource has service and ports mapping information. Check services. kubectl get SVC used to retrieve service list. This is Spring Boot service, cluster IP. There is no service type definition in the YAML file, so service use default service type cluster IP. The cluster IP is 10.101.107.165. The ports is 9999. Protocol is TCP. kubectl get endpoint used to retrieve endpoint's information. Endpoint name and service name is the same, Spring Boot and Spring Boot. There is one pod. IP is 172.17.0.3. Port is 99999. Next, check the pod's information. This is pod information. Next, go to pod, check the log to make sure our Spring microservice start up successfully. kubectl logs and port name start successfully. There is only one pod. Let me scale the deployment resource from 1 pod to 3 pods. The endpoint information will have all 3 pods IP address. kubectl scale deployment/deployment name minor replicas equal to 3 and minor record equal to true. The command is able to use the scale existing deployment resource. Get pod from 1 pod to 3 pod. Based on the age, we know there are 2 pods just created in 3 seconds. Check endpoint resource information again. Previous only has 1 pod IP address. Now there's a 3 pod IP address under the Spring Boot demo endpoints information. Cluster IP is not able to access from outside. So I start busybox pod to access my Spring Boot microservice. Let me start a pod to access Spring Boot demo. The pod is based on the busybox minor CURL image. The image is based on the original busybox image and plus CURL command. Because original busybox doesn't include CURL command. So I have to use busybox minor CURL image for my testing. The command is kubectl run minor it means interactive mode. Container name busybox minor rm after stop automatic delete. Image information restart never. Running command minor sh. The command used to access my Spring demo service. The command has 3 parts: CURL, IP address, and port. The entry point will return version information. The current should be v1. The information is correct. Pod busybox deleted because we used minor rm automatic delete. The command pattern same as Docker, just a little bit difference. Second topic. Why need service? Kubernetes provides service discovery function without modify application. So service registry center doesn't need it. The services are able to talk to each other use service name. How Kubernetes use service name talk to each other? There are 2 ways. One is environment variables. Other is DNS. Environment variables. When the pod is created, the environment variables was added to the container. But the environment variables doesn't support update on fly, so DNS more popular. Let me go to the inside container to check which variables created when the container start up. kubectl exec minor it and port name minor env. The env command will execute in the pod. There is useful information for Spring Boot demo service, IP address, port, protocol. Secondly, DNS. Kubernetes Service is able to talk to each other via DNS. Core DNS provide DNS service. Check core DNS status before my demo. The command is kubectl get pods and naming space kube system. Next, label information. We want to check the label K8s minor app equal to Kubernetes. Kubernetes is running. Next, I will check the service status. Kubernetes is running. And then launch a busybox pod to access Spring Boot service with NS lookup. kubectl run minor IT busybox minor im and image information busybox. This busybox has no issue with NS lookup. Their latest version is working perfectly with the DS lookup 1.28.4. Restart never minor s. Minor sh means when we log in this pod, the entry point is sh. Running NS lookup for service name. This command should return cluster IP for the Spring Boot demo service. That's right. Also, there's a full name for Spring Boot demo service. Since we use the busybox, there's no CUL, so we run wget command to access the Spring Boot demo service. Content is v1, it's right. There is alternative way we can check the DNS status. Use the DNS util that from Kubernetes. Create a pod. Run command ns lookup Spring Boot demo service. Exit the kubectl exec minor IT and pod name is DNS utils and the command ns lookup plus Spring Boot demo. DNS works. Auto try access Spring Boot demo in the pod DNS utils. Content should be v1. Let us go to latest topic for today. Service load balance types. Kubernetes is used to load balancing outside or inside network traffic to service. Kubernetes could be run a thread or daemon-side service on each work node. User space proxy mode. The mode was deprecated. IP tables proxy mode. The mode was added in Kubernetes version 1.1 and became the default operation mode version 1.2. In this mode, Kubernetes watches the Kubernetes control panel for the adding or remove of service and endpoint objects. For each service, it installs IP tables rule, which capture traffic to the service cluster IP and redirect traffic to the pod. IP tables proxy mode is default proxy mode. If Kubernetes cluster huge, maintain the IP tables is a nightmare and cause performance issue. So IPv6 proxy mode coming is good for the huge cluster. IPv6 mode is introduced in Kubernetes version v.8. IP table proxy and IPv6 proxy are both based on the Linux core net filter. What is the difference between IPv6 and IP tables? IPv6 provides better scalability and performance for the large cluster. IPv6 supports more complex load balancing algorithms, such as minimum load, minimum connections, location, etc., than IP tables. IPv6 supports service health check and container retry. How do we check Kubernetes configuration information? The command kubectl get naming space kube system configure map with kube proxy minor YAML. The command will give you current Kubernetes configuration information. IP tables config, IPv6 config. The mode value is empty. That means use default proxy mode. The default proxy mode is IP tables. Next, login Minikube virtual machine. The command used to check, is this a virtual machine, load IPVS mode. Answer is empty. That other evidence show us the Minikube used IP tables proxy mode. Latest check Spring Boot demo redirect rule in the IP tables. There are two rules added to the IP tables for Spring Boot demo service. In the production environment, CNI plugins such as Final Critical will use for the network setup because they have more manageable network traffic and high performance than Kube proxy. Today we learned Kubernetes core concept service include topics such as service definition and full service type, and how to create a service via YAML file, and service load balance type. Thank you for watching. See you in next class.